All right, I found some time to make a video of the formulas. I know yesterday we just finished our last lesson, and or for some of you 2 days ago, depending on what block day you're on. But I wanted to show you guys all of the formulas. Now, I hope that this formula sheet actually clarifies some things, not makes it more confusing. This is literally every single formula. So I know it says chapter 10 formulas, but it's literally every single type of formula we've done so far. My hope is that you can compare confidence intervals to significance tests, one proportion interval to one proportion test, but then notice that it transitions to two sample down here. And then we've got all of the means. So I'm hoping that you can see the similarities, yet the differences. Now, technically, Chapter 10 is all going to be down here. Everything we did in Chapter 10 is going to be these formulas down here. So I'm just going to kind of quickly go through them and remind you guys what those formulas were. So over here it says the mean and the standard deviation of the sampling distribution. So remember, we're using sampling distributions with proportions. We're only taking one sample. So the mean of the p-hat, if it's a confidence interval, we don't know the true p, so we have to use the p-hat as our best guess. And then the standard deviation of the sampling distribution is the p-hat times 1 minus p-hat over n. Remember, we like to call that standard error because we're using sample data, not actual data. Now, I actually could draw a line here and separate them because when we have a significance test, the mean of the sampling distribution of p-hat, we actually have a claimed one to use, the p. We're going to use that formula instead. And then when it comes to the standard deviation of the p-hats, again, since we have a claimed p, we're going to use p times 1 minus p over n. So the difference between a confidence interval and a significance test is the confidence interval, you have the sample data. In a significance test, you have the actual data. Okay? So those are the formulas for the mean and standard deviation of the sampling distribution. Now, in a 1 proportion z interval, remember we've got this general formula. Stat plus or minus the critical value times the standard deviation of the statistic. That's the formula we always use for an interval. And when I plug in my information, well, the statistic is p-hat plus or minus, we have a z star times the standard deviation of the statistic is the p-hat times 1 minus p-hat over n1. We have to use the standard error since we don't have a proportion to work off of. Now that's the general formula for confidence intervals. But remember, when I transition to significance tests, it's a different formula. We use the test statistic formula. So if you remember, the test statistic formula is equal to the statistic minus the parameter divided by the standard deviation of the statistic. Okay? So this is the general formula that we can turn around and plug into the pieces for the specific. The test statistic on a proportion is always a z. That's equal to the statistic of p-hat minus the parameter of p divided by the standard deviation of the statistic, p times 1 minus p over n. Okay? So this is what's going to help you find the z-score in a significance test when it's a 1 proportion z test. Now, this is all last chapter stuff, okay? This chapter, we transitioned to 2 sample. Remember, we're comparing distributions. And again, I'm going to split these because there's a slight difference between them. When you use the sampling distribution for a confidence interval, we're going to use p-hat 1 minus p-hat 2 because we don't have a claimed p to go off of. Okay, and then we're going to use the square root of p-hat 1 times 1 minus p-hat 1 over n1 plus p-hat 2 times 1 minus p-hat 2 over n2. Because again, we don't have an actual p to go off of, so we have to use the standard error formula. All right? When we look at the sampling distributions of a significance test, we're saying that the mean of p-hat 1 minus the mean of p-hat 2 is going to be equal to the true mean, or the true proportion of the first minus the true proportion of the second, so the actual parameters, which we always end up saying it's 0 because there's going to be no difference between them. But in the standard deviation of the p hat 1 minus p hat 2, I talked about this Wednesday of last week. The idea that in a two-sample test, the null hypothesis is that we're claiming that there's no difference between these. So in the sampling, the standard deviation, we need to assume there's no difference. So we can't use this formula. Remember, this is where we have to combine the p hat. So we use the p hat c times 1 minus p hat c over n1 plus p hat c times 1 minus p hat c over n2, because we are assuming that there is no difference between the two parameters. So we have to use the p hat c version. So those are the two biggest differences between confidence intervals and significance tests. When we get to the two proportion z interval, okay, again, we have a general formula. It's statistic plus or minus the critical value times the standard deviation of the statistic. It's always the formula in an interval. Then I'm going to come down here and do the specific version. Well, the statistic for a two proportion is, remember, p hat 1 minus p hat 2 is the statistic. Plus or minus, the critical value is still z star, but it's times the standard error formula, the p hat 1 times 1 minus p hat 1 over n1 plus p hat 2 times 1 minus p hat 2 over n2. It's that formula that I wrote up here. Okay, so that's all the confidence intervals. Now you can compare the one sample to the two sample. Again, this is what we did early last week. Now, two proportion z-test, we have this formula up here. Test statistic equals the statistic minus the parameter divided by the standard deviation of the statistic. All right. Well, we already know that we can plug in the specific pieces to get the specific version. So again, the test statistic we're using is z, and the statistic is the p hat 1 minus p hat 2. It's the difference between our samples. So if that's the statistic, our parameter is p1 minus p2, and we're going to divide by the standard deviation of the statistic, which I already wrote up here. It's the combination one. We are assuming that there's no difference between the samples. So the p hat c times 1 minus p hat c over n1 plus p hat c times 1 minus p hat c over n2. So again, these are the main formulas you guys need to know for Chapter 10. My goal here in this sheet is to be able to compare your one sample stuff to your two sample stuff. So this is actually going to be more beneficial at the end of the year when you're trying to review all of it. Okay, but focus on the two sample stuff for Chapter 10. I'm going to go ahead and stop the video now since we're done with proportions. I'm going to start a new video for means. So go ahead and see the next video.